Here I have an equation which includes logarithms. Now in this case, the variable is not up in the exponent. So frankly, I don't want the logarithms, and I'm going to try to write this equation without using logarithms. The rule that I'm going to use eventually is that the log base a of b equals c is equivalent to b is equal to a to the c power. In order to use this rule, I'd need a single logarithm over on the left. So instead of expanding logarithms, I'm going to contract these logarithms. The log of a product is the sum of the logs. So I could rewrite this as the log of the first times the second. Now I have something of this form. The log base 10, since it's common log, it's assumed to be base 10, of x times x plus 3 is equal to 1. That means that what's on the inside, the x times x plus 3, that's my b, should equal my base, that's 10, to this power. Instead of writing x times x plus 3, I'll write that as x squared plus 3x. I'm tempted to factor, so I move everything over to one side. X squared plus 3x minus 10 equals 0. Factors as x plus 5 times x minus 2. So either x will be a negative 5 or x will be a positive 2. Now both of these answers make perfect sense here, here, here. Even here, though one of them is going to strike us a little bit strange. The problem is actually when I plug this number, a minus 5, into my original equation, because I'd have to take the log of negative 5. Now, since base to a power, since 10 to a power is always going to be positive, I can only take the log of a positive number. Remember that logarithms undo exponentiation. So this apparent answer, x equals a negative 5, doesn't work. On the other hand, with 2, that would just be the log of 2 plus the log of 5 is 1, and log 2 plus log 5 would be the log of 2 times 5. That would be the log of 10. And that works. The log of 10 is 1. So this answer doesn't make sense in the original. This answer does.